Hello, Mustafa AÐGÜL speaking. In this lecture, we will continue our discussion on trigonometric function. Especially, we learned cosine and sine functions. For any real t, the cosine of t, abbreviated to cosine t, and sine of t is abbreviated to sine t, are the x, y coordinates of any point corresponding to the angle on the unit circle. So if you draw a line representing the angle, you will see it will intersect with the circle at some point, and we say the x coordinate of this point is the cosine value of this angle, and y coordinate of that point will be our y axis. So here it is also given there. So let's move on. Also, let's continue with some known cosine and sine values. For example, if we are with this information already, so if we consider unit circle and angle 0, then it means we are at this point, okay? This point. So the x-axis of this point, x value of this point is 1. That means our cosine value at this angle is 1. So cosine 0 has to be 1. Okay, similarly, we have the y coordinate is equal to 0, so that means we have sine 0 is equal to 0. Okay, let's move on to the next angle, pi halves. So at this point, we know the x coordinate is 0 and y coordinate is 1. So our x coordinate is 0, y coordinate is 1. So that means cosine is 0 and sine is 1 at that point. Okay, move on to the next angle. We have angle pi. At that point, we have x is -1 and y is 0. So it means our cosine value is -1 at pi and sine is 0. Okay, the last one is negative pi halves or 3 pi halves. We will see x coordinate is 0 and y coordinate is -1. So that means our cosine negative pi halves or cosine 3 pi halves is equal to 0. And sine negative pi halves, or say sine 3 pi halves, is equal to -1. So these are the well-known values of cosine and sine functions. Oh, okay, so whenever you stuck with the values, you can always draw a unit circle and then identify their values easily using this strategy. Okay, what is the range of sine and cosine function for any real number? So cosine value has to be between -1 and 1. Similarly, sine will remain in that interval as well. Okay, why is that so? Because we know cosine is the ratio of the length of the adjacent side divided by hypotenuse, and we know adjacent side cannot be, the length of the adjacent side cannot be more than the hypotenuse. That's why the ratio can be at most 1 or -1. Okay, so these are the range. Then we will use Pythagorean theorem to find this identity, and this identity comes from this reality. We have unit circle, and we know this is the angle, say t, and then if we draw the triangle here, we know this is our hypotenuse, this is our cosine t, and this is sine t. Then using the Pythagorean theorem, then we will see cosine squared t plus sine squared t is equal to 1, because we know the radius of the circle is 1. Okay, so this comes from that Pythagorean identity. Okay, so we have to make sure we don't confuse with this notation, because we put squared right after s here and n in sine, and that means we really take the cosine of, squared of the parentheses of s cosine. Okay, so it means cosine t parentheses squared, not cosine of cosine or anything else. Okay, we need to be careful with this notation because it's everywhere in the literature. Okay, so periodicity, we say if we add 2 pi arc length to any arc length, we will end up at the same point. Okay, so let's again consider the unit circle. Say we are here at this point. If you add 2 pi, or if we move 2 pi along the circle, we will end up at the same point, because we know 2 pi is the circumference of the circle. Okay, so that means adding 2 pi to an angle will result in the same sine and cosine values. Okay, so instead of, for example, saying cosine of t plus 2 pi, we can say just cosine t. Similarly, we can say instead of t plus 2 pi, sine of t plus 2 pi, we can say sine t. That's all we need for periodicity of cosine and sine functions. So this means we have period of 2 pi. Whenever we add 2 pi to the angle, we still are at the same angle. Okay, let's also talk about some identification of the functions. Cosine function is an even function, and sine function is an odd function. Okay, this is even. What was even and odd functions? Whenever we put negative for the input values, negative t instead of t, we end up with the without negative form of the function. Okay, so this is cosine negative t is equal to cosine t. And for the odd functions, we have the opposite. That means sine of negative t is equal to negative sine t. Okay, so this means we have sine to be odd function and cosine to be an even function. Okay, complementary angle identities. First of all, what is complementary angles? We say two angles are complementary if they add up to 90 degrees or pi halves. Okay? So, for example, if we consider angle T, the complementary angle with that T is pi halves minus T, because when we add these two quantities, two angles, we will end up with pi halves. That's why we say they're complementary angles. Okay, what's happening with this complementary angle identities? Whenever we work with complementary angles, say we have two complementary angles, the cosine of first will be identically the same with the sine of the other. Okay? This is to say that. Okay? So this is the first angle. Say this will be sine of first will be cosine of the other. Okay? Similarly, we say sine of the second is equal to the cosine of the second is equal to sine of the first. Okay? So supplementary angle. What is supplementary angle? If two angles add up to 180 degrees, then we say they're supplementary angles. Or similarly, we say if they add up to pi degrees, they are the same, you know. We say they are supplementary angles. Okay. Then let's see what happens with these angles. If you're working with supplementary angles with, for example, t and pi minus t, we know they're supplementary because whenever we add these two, we always end up with pi. Okay, so t and pi minus t, when we consider these two angles, cosine of second, for example, cosine of second is equal to negative cosine t, and sine of second will be the same with the first, sine of the first. Okay, so this is something else you need to know. Okay, some special angles. Let's see what happens with these angles. For example, 0, 30 degrees, 45, 60, 90, 120, 135, 150, and 180 degrees are special functions, angles. So their radian counterparts are 0 and pi sixth, pi fourth, and so on and so forth. You can see from the table. Their cosine and sine values are given on that table. You can find this information also on your PDF notes. So you can, I address you to your PDF notes to memorize this information and their corresponding triangles. Okay, if you need to give a break, you can pause the video here and check the table for a while and then keep going. Next, we will show you the graph of cosine and sine functions. First, y is equal to cosine x is some sort of wavy function like this. It continues because we know it's 2 pi periodic. So whenever we move 2 pi, it will be the same pattern. So let's consider on this interval only. Okay, we know cosine 0 is 1. As you see, it is 1 here. And cosine pi half is 0. That it's 0 here. And cosine pi is -1 and it's here. And so on and so forth. We can go on to the negative direction as well. Okay, for the sine, though, it's just pi half degrees shift to the right. Okay, so that means you know, this makes sense because we know if we are working with complementary angles, their sines and cosine values will be the same. So this is basically sine of 0 is 0, sine of pi half is 1, and sine of pi is 0, so on and so forth. Okay, so some trigonometric identities. Addition formulas first. If we have cosine of sum of t plus s plus t, then it will be equal to cosine of the first, say this is first and this is second, cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay? Similarly, you can read the other formulas as well. So this will be, say, first and second. Sine of s plus t, we will have sine of first plus sine of first times cosine of second plus cosine of first times sine of second, sort of. Okay, so you can follow the same pattern and you need to memorize these addition formulas. Okay, next we have an example. It says find the cosine value of 15 degrees. Okay, to do that, let's go back to the addition formulas and see how we can end up with this this quantity. We know cosine and sine values of the 45 degrees, 45 degree and 30 degree, right? And we know if you subtract 40 from 35, we can end up with 15. So this is what we really need. So we can rewrite this as 45 degrees minus 30 degrees, right? So can we use any of this identity to end up with this quantity, really? So this will be, say this is 45 and this is 30 degrees, then we will end up with 15 degrees, right? So it means we are working with the third identity. So it is cosine of first times cosine of second plus sine of first times sine of second. Okay, let's use this identity. So it will be cosine 45 minus 30 degrees equal to cosine of first, so 45 degrees times cosine of second, 30 degrees. It is plus, in between we have sine of 45 degrees times sine of 30 degrees. Okay, cosine 45 is root 2 over 2. You can check from the table as well. So cosine 30 is root 3 over 2 plus sine 45 is root 2 over 2 times cosine 30 is 1/2. So as a result, we will see this will be root 6 over 4 plus root 2 over 4. As a result, we can say this is root 6 plus root 2 over 4. So we found the cosine value of 50 degrees. Thank you.